Hey, Mark.
Hey, David.
How are you doing today?
Good, how are you?
Good. You sending me anything, or I probably
No,
already
just
have.
that stuff from before.
What's that?
Just the stuff from before.
Okay. Let's see. Before, what was that material? Unfortunately, I might not still have it on my desktop. Was this stuff you sent me Tuesday?
Yeah.
Let's look at my emails on Tuesday. What is today? The 3rd, so that would have been the 1st. There it is. And go ahead and put both of these back on my desktop. So yeah.
That's it.
How far did we get through this page?
I think we had finished the front page.
We'd finished the front page, all that you needed to do? That's right, I remember doing the M and the N. Okay, open up the second one. Okay, yeah. Yeah, this is what I've been working with everybody on. So it's what I call linear area and volume ratios. So let's look at number 8.
All right.
Wow. So I guess we're supposed to know that little h is the height of the small pyramid and big H is the height of the large pyramid?
Yeah.
Okay. So which ratio is that? Is that R sub L, R sub A, or R sub V?
L? No, V.
Yeah, I would say R sub L. Huh. Just a second. I'm going to have to pop this thing back open again to get it to work. Yeah, all right. So R sub L is what?
4/7.
Okay. Your teacher always goes small to big?
Yeah.
All of my students are like that. To me, it seems so much easier to go big to small. And I'll show you why. What's R sub A? We don't even need R sub A, do we? Well, I guess we do.
No.
They ask it here.
16/49.
Okay. And what's R sub V?
1 second. 64 over 343.
So that's the ratio of the small volume to the big volume.
Mm-hmm.
Now, give me a ratio equation that I can set up that solves for our answer. In other words, because they've given us the small volume. So what can I say in terms of an equation?
4/7 equals 320 over x.
What did you say again?
4/7 times 320 over x.
Well, what we have to make sure is that we get it in the right order. 4 over 7 is, actually that's the linear ratio. That's no longer a factor. In other words, what we have is the ratio of the volumes is 64 is to 343 as the volume of the small pyramid is to the volume of the large pyramid. You see how I got that ratio?
Hmm.
In other words, we went through and calculated all of these R's so that we could figure out what the volume ratio was going to be.
Okay.
And once we had this volume ratio, you can see that the big volume is about at least 5 times bigger than the small volume. So X is going to have to be at least 5 times bigger than 320. And now it's just a question of doing the arithmetic. So coming up with the answer isn't the hard part. Coming up with the setup, the equation, is what's tough.
All right.
Okay? So just always make sure you're going in the right direction. You don't want to go from big to little, and then on the other side of the equation, go from little to big.
Okay.
Okay? All right, let's look at number 9. Let's go through. There are 3 things, R sub L, R sub A, and R sub V. Turns out that once you get the answers to these 3 questions, everything else kind of falls in place.
Okay.
What information have they given us that allows us to calculate one of these 3?
The volume?
So what's the volume ratio? And let me encourage you to do large versus small. I don't think your teacher's going to care, is he?
I guess.
Or would he? It's not going to matter. It's okay. Let's do small to large. It doesn't really matter.
Okay.
So what's the linear ratio? Excuse me, what's the volume ratio? What's R sub V?
12 over 76.
Is it 76? I think it's 768.
Oh, yeah.
Right?
Mm-hmm.
And from that, we can figure out the other 2 ratios. Now, my understanding is the way they teach it at Chatfield is they don't teach you to do the area one directly. They teach you to go back and figure out the linear one and then square it to do the area one. We need the area one to answer their question because their question has to do with the surface area of the large one versus the small one. So we need the area ratio. But first of all, let's get the linear ratio.
That'd be 4 over, no.
No? How do you get the linear ratio from the volume?
Find the cube root of 12.
Okay. See, where you're going here, though, is you're going to end up with decimals.
Yeah. So...
That's okay. I mean, you can go ahead and put that quantity in your calculator and take the cube root of it. What does it give you?
Cube root of 12 over 768 just gives me a decimal.
What is that decimal?
2.28.
Don't think so. here's the thing. Do this in your calculator. What's 12 divided by 768?
0.015.
Now take the cube root of that decimal.
0. The cube root?
Uh-huh.
All right.
Right? Because what we're looking at is the ratio of the volume, and the way we get the linear ratio is to take the cube root of the volume ratio. Go ahead and tell me what your calculator says, because this is where the problem comes in. What's 0.015 raised to the 1/3 power?
0.00003375.
Hold on a minute. Let me open up my virtual calculator. And do it. Okay. So, let me clear everything. We got 0.015. And just for the sake of argument, I don't really like saying 0.015. I don't need that leading zero on the left side of the decimal point. That's presumed if I don't say it.
Okay.
Okay? Is all it does is that when you're verbalizing it, it throws out too many zeros and it actually makes it harder to figure out. So I'm going to raise that to the 1 divided by 3 power. Now, this is why it's confusing, is because that number gets bigger when you take the cube root of it. You see that?
Yeah.
When you take roots of numbers less than 1, they get bigger. When you,
Okay. I thought I had done that wrong.
When you square numbers less than 1, they get smaller. In other words, if you square 1/2, it becomes 1/4. But if you take the square root of 1/4, it becomes 1/2. And it's a bit counterintuitive, and people, I mean, you have to deal with it. That's the way math is. But it's a little tough. Now take this number and square it, and that's going to give you your area ratio.
Okay.
You want me to do it here?
Sure.
0.246. Actually, that's not the right way to do it, is it? No, the right way to do it is, well, I'll give you an approximate answer. 2.466 squared is, notice it gets smaller as it should. So there's the area ratio, and that's little to big. And the reason I advocate for always doing big to little is, notice if we did big to little, the volume ratio would be some number. It would be like 60. And then we'd take the cube root of 60, and we'd have a number smaller than 60. In other words, we wouldn't be dealing with decimals and fractions. That's what I object to in terms of doing little to big as opposed to big to little. If you do big to little, you're always dealing with whole numbers, numbers bigger than 1. And that makes it easier, really, to conceptually understand it and also apply it.
Okay.
Okay, but if your teacher insists upon doing little to big, and it sounds like he might, because I have another student that has a different teacher and they have to do it that way also, we'll do little to big. There's nothing wrong with doing little to big. It just seems to me that it creates a harder understanding of it. So how do I get, if I know the surface area of the large cone, which is 384 pi, what's the surface area of the small cone? How do I get it?
You could do 12 over 700. No,
that's volume.
So you could do 0.0608 times.
There you go.
384.
384 pi, right?
Yeah.
And that's what the answer is going to be. So in this particular case, it actually came out rather nice because they wanted the small cone. And we're going to take the large cone and multiply it by this number that's less than 1, obviously, to get the small cone. So if they had given us the small and wanted to know the large, then we would need to divide the small by this number, not multiply by it.
This is a separate question, but how would you find the mean of a few points of data?
Add them all up and divide by the number of points.
Okay.
In other words, if I have these three numbers and I want the mean, it's 1 plus 3 plus 7 divided by the number of numbers, which is 3.
Okay.
That's the mean.
All right.
It's also mode and median. Are you doing statistics right now in geometry?
No, it just popped up on a test, and I needed to make sure I knew it.
Okay. Mean means the same as average.
Okay.
Okay? Whereas median means middle. Okay, so let's look at number 10. Which ratio have they given us the data to figure out directly?
For 10?
Uh-huh.
Which
of those R's are we going to be able to figure out first?
Area.
Okay. What's that ratio?
108 over 300.
Give me a decimal for that. And the reason is it's going to be easier to take the square root of the decimal than it is the top and the bottom.
Okay, so take 108 and then divide it by 300.
Uh-huh. What do you get?
0.36.
So now let's go backwards and figure out the linear ratio.
Okay, so 0.36. It's 0.71.
And now the volume ratio.
0.046.
You took that number and cubed it?
Yeah.
Okay. So now they've given us one volume, the small one. How do we get the volume of the large one?
Multiply 324 by 0.046.
That's going to give us a smaller volume if we do that.
Okay, so we take...
Either you have to multiply it by that or divide it by that, depending on whether you need a bigger volume or a smaller volume. Well, we can tell that they've given us the volume of the small one, so the volume of the larger one has to be bigger. Okay. The only way I'm going to get a bigger number is to take that number and divide it by that number.
Okay.
Okay. So what do you get when you divide 324 by 0.046?
7,000. 7,443.
Seems strange, doesn't it?
Yeah.
But it's not. Although, let me think about that for a second. I'm just going to show you the way I would do it. Let's make sure we get the same answer. I'm going to divide 300 by 108. Go turn it on first, I guess. 300 divided by 108, that's going to give me that ratio. But notice that it's not 0.36, it's 2.77. Because I'm doing big to little, not little to big. Okay, and now to get the linear ratio, I'm going to take the square root of that. And now I've got also a number that's bigger than 1. And now I'm going to cube that number. In other words, all my numbers are bigger than 1, and they all make more sense to me.
All right.
Now, when I go to find the bigger volume, I know the volume ratio is 4.6, so I have to take that small volume and multiply it by 4.63 to get the big volume.
Okay.
And as all this tells me is that we made a mistake in our math doing it the other way. In other words, yeah, we're missing a decimal place here. No, we're not. Ooh. Why are these digits the same here? It doesn't make any sense. Hold on, let me do on my calculator here. All of the same calculations you did. We started with 0.36.
Mm-hmm.
Took the square root of that. We got 0.6, not 0.71. Actually, excuse me, let me do this again. We started actually with 108 divided by 300, correct?
Yeah.
Okay, that is 0.36. Now I'm going to take the square root of that. And I get 0.6, not 0.71. Okay. And now I want to cube that. And I get 0.216. So it's not 0.046, it's 0.216. And now notice that if I take my volume, which is 324, and divide it by 0.216, I will get the same answer as if I take that volume and multiply it by my number, 4.63.
Okay.
So it doesn't really matter whether you use small to large. It's just that if you go small to large, all your ratios are going to be decimal. They're going to be less than the number 1. And then when you start cubing them and taking square roots of them and stuff, it's harder to see whether you've made an error. It just is. We made errors when we did it small to large, and we didn't pick it up. In other words, I didn't notice it because who the heck knows what 0.71 cubed is. Whereas I know that when I cube that number, approximately what the ballpark number should be. I know that 2 cubed is 8, 1 cubed is 1, so at a minimum it's got to be between 1 and 8. And it is, it's 4.63. So when I use big to small on the right-hand side here, it just makes more intuitive sense. And in fact, this one's easier to get this answer because all I have to do is take that and multiply it by my 4.63. It's the same as dividing it by 0.2616, but to me it just seems like it's less likely to make a mistake if you do it big to small. So what you're telling me is if you put down 1.66 there, the teacher might not like it because you didn't go small to big, you went big to small?
Yeah.
Wow. Okay. We'll keep going small to big. It doesn't matter. We're going to come up with the right answer either way. So in this one, what do we have?
You've got the volumes, and it's...
So we have R sub V.
Yeah.
Okay, what's that going to be?
1,944 over 4,608.
And there's a pi on top and bottom, but those are going to cancel. What does that decimal equal?
Let me look.
Now that is the way he wants you to do it, is it not? Convert it to a decimal?
Yeah, it is.
Because otherwise we're going to be taking cube roots of these big numbers and we're going to have decimals over decimals.
Well, sometimes we use fractions instead.
Well, if it's a certain kind of fraction, yeah, if this was 64 over 27, it would make perfect sense to leave it as a fraction the whole way.
Yeah.
Why? Because the cube root of 64 is 4, the cube root of 27 is 3, so everything is nice. But when you're dealing with these kind of numbers, I just have this feeling that the cube root of that is not an integer, and the cube root of that might not be an integer. So you're going to end up with a decimal over a decimal. That's not going to be helpful. So let's just go ahead and convert this whole thing to a decimal immediately.
Could we just keep it as fractions the whole way?
Well, you'll see what the problem is.
Okay.
What's the linear?
Well, the linear is 1,944 divided by 4,608.
Huh?
Okay, so we have 27 over 64, and then we have to find the before that, so...
Hold on, what did that... In other words, you need to take the cube root of this number.
Yeah.
Okay, what's your calculator giving you when you do that?
Let me look. I'm just trying to input it right now.
Okay. It's going to be a whole lot easier, and I'll show you why, if we convert this to a decimal immediately.
Okay.
But let's keep going, because a lot of times a person learns something by doing it the hard way. What's the cube root of 1944?
Hmm. 1944. It's 132.2.
And what's the cube root of 4608?
It's 16.6.
Don't think so.
Oh shoot, I did that one wrong.
All right. Well, you can see what's going to happen. I'm going to end up with a number, and then I'm going to have to either square top and bottom again, so I have another ratio when I get the area ratio. But eventually, I got to convert that to a decimal.
Okay.
Okay, so let's just convert this to a decimal, and then we can do all of our cube rooting and squaring based on that decimal. So what is this number right here? What's 1944 divided by 4608? This is another reason I don't like going small to big, is it makes all of these misunderstanding problems.
It's 20. Well, let me turn it into a fraction, actually.
1944 divided by 4608. Real simple.
Yeah. It's 0.421.
Now take the cube root of that number.
All right. So
just raise it to the 0.333.
Sorry, I'm trying to use the fancy calculator for this. Right. And then we're raising that by what?
We're going to take the cube root of it, which means we're raising it to the 1/3 power or raising it to the 0.3333 power.
Okay. So I got 0.64.
Okay. Now square that number, and you're going to have the ratio area, the area ratio.
0.40.
Impossible. The area ratio has to be midway between the volume and the length. And you've got it less than the volume. So
0.64 squared, it came out with 0.4096.
Okay, here's what I suspect you're doing in your calculator. I suspect you're not using parentheses. In other words, you're taking a number and maybe taking it to the 1. In other words, you're raising it, you're using that thing, but then when you put 1/3, you don't use parentheses. And it's screwing it up. Because this answer is impossible. You can't take the cube root of 0.42 and get a number and then square it and get a number smaller than what you started with. And this whole problem is only because we're going small to large. If we were going large to small, this would disappear. This would be so much easier. Now, understand that the only difference between small to large and large to small is one is the reciprocal of the other.
Okay.
Okay? I've got to go now, so I can't really continue on here. But what we have here is a calculator problem. You're doing these cube roots and squares wrong to come up with these 3 decimals. And you have to figure out how to do it right on your calculator. Do you have an Inspire or a TI-84?
I have TI Inspire.
So you have the Inspire. Okay. It's the same process on the Inspire. When you take something and take a cube root or square it or cube it or any of those processes. It's the same on the TI-84. In other words, you have this little arrow here. That means you take a number to an exponent. So if I'm taking 0.42 and I'm taking the cube root of it, watch, I got to put parentheses in there. 1 divided by 3 end parent. You see how that line reads?
Yeah.
That's the cube root of that number. It gave me 0.74, which is not what you gave me. You gave me 0.64.
Okay.
So you must have done that wrong. And then I got to square this number to get the area ratio. So I raise it. And this time I can just put 0.5 and I don't need parentheses because I'm not raising it to a fraction. And so that's the answer, 0.86. I don't know what's going on here. Oh, I didn't mean to take the square root of that. I meant to square it. I apologize. I meant to square that number, and I
Okay.
accidentally took the square root of it. And when you square that number, you're going to get something in the area of 0.5. But yeah, you need to figure out how to square and square root numbers on that calculator. You're not going to be able to do any of these problems until you get that down. It'd be a lot easier if you went big to little, because then you wouldn't have decimals to deal with. Everything would be a number greater than 1. But anyway, we can talk about that later.
Okay.
I'll talk to you next Tuesday.
All right. Thank you, Dick.
You're welcome.